Welcome back. I'm here with Swifty7777. Say hi.
Hi.
Hi. We are going to continue talking about math in Minecraft. So last time, if you watched the previous video, we talked a little bit about different kinds of numbers, even, odd, prime, and square numbers. And so Swifty built this pretty epic coliseum for us to work in today. You can see there's kind of an...
And the numerals.
And the numerals. He did all of this entryway where you spawn, and then there's this nice kind of gated area where we can keep the animals out while we do math. And then over here we've got kind of the stair-step pattern of the Cuisenaire rods. So that's a 1, 2 red, 3 light green, 4 purple, 5 is yellow, 6 is dark green, 7 is black, 8 is brown, 9 is dark blue, and 10 is orange. So that's just a reminder for us. And over here we've got, we're going to do some addition and we're going to do some multiplication, and we're going to talk about how they relate to each other a little bit. Okay, so last time we built out all the multiplications from the numbers 1 through 10. And so we just pulled out one number here. This is, what number is this, Swifty?
6.
Okay, dark green. It's a little hard to see against the grass, but it's a 6. It's 6 wide. And then below it, what's this represent here?
6 times 1.
6 times 1. And then what's this next one? 2 rows of...
3.
So that's...
2 times 3.
2 times 3. And then this one...
3 times 2.
3 times 2. Okay, so we're going to do some additions now. So what we want to do is we want different ways to build the 6 out of 2 blocks. So let's do that. And I'm going to dump some glass in between them, again, like we did last time, so that we can see where the divisions are, because it's hard when they run together and they're the same color. Great. Okay. Oh, sorry. We got to put one in there. There we go. Okay. Okay, just stop for a sec. So let's go through and just kind of talk about what this is. I'll put a glass at the end of this one so they all look alike. Okay. Okay, so the glass doesn't mean anything. It's just a joining thing. So this first one is, if it were an addition, it's 6 plus 0. Hey, look over here.
Yeah.
So what's the second one? Read them off for me.
5 plus...
Oops. Start from the left to right.
1 plus 5.
1 plus 5, then?
5 plus 1.
Okay, then?
2 plus 4.
And then?
4 plus 2.
And then?
And of course 3 plus 3.
Of course 3 plus 3. Okay, so let's do a few more now with 3 blocks.
Okay, so the first one would be 4 plus 1 plus 1.
Okay.
Second one would be 3 plus 2 plus 1. I got that.
Okay. The power to change the weather. Let's see. Can I just change it to clear? There we go. We're all good. It'll stop in a second. Okay, go ahead. Okay, so
I'm not gonna go through the backwards one because that's kind of obvious.
Yeah,
so
that would be
I don't want to do 1 plus 1 plus 4.
Okay.
So I'm just gonna do one of those.
Great. That would be a lot of extra ones, but just everybody should know that there are many combinations of these. If we mixed up the 4 plus 1 plus 1, it could be 1 plus 4 plus 1. That's a good point. Okay. And read them off as you do them. What was that previous one? Ooh. Okay, so now we're actually going to do the last one we'll do with all just single blocks. So that's going to be a really long one. Is it running into the other one? Is it okay?
Wait,
okay, we're good.
Wait, I just need to replace this because I got out. Okay.
Okay, so read those last few off. Starting here.
Starting here.
Here.
At the reds. 2 plus 2 plus 2.
Yep. Okay, and then?
1 plus 1 plus 1 plus 1 plus 1 plus 1, which is the same as 1 times 6.
Well, let's hold off on that. Okay, so terrific. We've built all of these additions and we have the multiplications now for the number 6. So we can kind of compare them visually side by side, which is what we wanted to do. All right, so let's start again. Last time we talked about numbers. So remind us, what is a number?
A quantity.
A quantity of stuff. And so we can see those quantities here. When we read these off, we're calling this 6, but we can see that it's 6 things is why we're calling it 6. Okay, and we already said the multiplications. We've gone through all the additions. So the question is, what is addition? The next question is, what's addition?
Addition is when you combine two numbers to equal basically another number. You're combining two numbers to equal another number.
Right, okay, great. We can see them all here. We're just joining numbers together to make bigger quantities, right? Or joining quantities together. And so we use the plus sign and all of the symbols to represent that, but really what's going on is this kind of joining operation. You're putting stuff together. And what about multiplication? What is multiplication?
Multiplication is when multi means multiple, and ply means layer, and so it's basically several layers.
Okay, so thinking about the word, that's very good. That's very good. No, I know. We talked about that before, but I didn't realize that it had kind of stuck. So if you look at the word multiply, it means many layers, right? So you're exactly right. That's what we've got going on here. So if we look at the relationship here between addition and multiplication, do you notice any sort of connections and relationships?
You see the 6 times 1.
This here.
Then you've got different form of it at the bottom of the other one, of the other column.
Okay, so this is 1 plus 1 plus 1 plus 1 plus 1 plus 1 is 6 times 1.
Yes.
Okay, so what else? Do you see any other patterns that connect?
It's the same with the green and also the red.
So the green here, this is?
It's 3 plus 3, which we have over
this is 3 plus 3.
On the left side.
This is actually 2 times 3,
yes.
Right? And that's the same as 3 plus 3.
Yes. And then you've got 2 times 3, which is the same as 3 times 2. I mean, 2
okay,
times,
so this
3
is
times 2 or whatever.
3 times 2, and it's the same as?
Same as 2 plus 2 plus 2.
Great. Okay, so there's this connection between them. And are there any so why do we only have 4 of the multiplications and we have 7, 8? We already made 10 additions for 6, and we haven't even done, we haven't even done them all. There's so many more that we could do if we wanted to list them all out.
Yes.
Why are there so many more additions than multiplications? For example, why is this 1 plus 5 not in the multiplication column? Why is there no yellow on the right-hand side?
Because you're adding 2 numbers, you're combining them, like I said earlier.
No, I know, you're combining them, but why can't they be put over here?
Because it's not the same number.
What isn't the same number?
1 and 5 are separate numbers.
Okay,
and they're different, and you can't multiply everything. Multiply, you have to have different groups of the same number. The first one and then the second one. The first one is like how many groups, and the second one is how many numbers are in the group.
Very good. Okay, right? Well, so people argue about which is which, but you're exactly right. One of them is the multiplier, and that tells you how many layers there are, and the other one is the multiplicand, and it tells you how wide the layer is. So the multiplicand here is 2, that's how wide the layer is, and the multiplier is 3, because that's how many are stacked up. So what you just said is, if I can summarize, tell me if I got it right, the only additions that make it into the multiplication column are the ones that are adding the same number over and over. So this one makes it because it's all 1s, this one makes it because it's all 2s, this one makes it because it's all 3s. And nothing else can be over here.
Nothing else can be over there.
Nothing else can be over there. Because what's the relationship between multiplication and addition?
You're both combining numbers, except in different ways, kind of.
Right. But multiplication, one way to think about it is that it's kind of a repeated addition.
Right.
But not everything can be grouped. Not everything can be grouped in ways that can be multiplied. So let's talk about the commutative property. Do you remember what the commutative property is?
It's kind of, I'm not quite sure how to explain it.
Well, can you give me an example of the commutative property of addition from this list?
3 plus 3 is the same as 3 plus 3.
Well, that one, yes.
4 plus 2 is the same as 2 plus 4.
Okay, so you can see the commutative property of addition right here, right?
Yeah, right
this
there.
This is where you're pointing. 2 plus 4 is the same as 4 plus 2. Now, for addition, why is that true always? You can see it here, right? Why is that always true for addition?
Because, well, you're not really changing anything. You're just doing it in a different order. It's the same numbers.
It's the same quantities of stuff. So for addition, what you're saying is addition's a joining operation. We're putting 2 different quantities together to make a bigger quantity. It doesn't matter what order you join them in, right?
Yeah,
because you'll end up with the same result. That's why commutativity is true of addition. So for multiplication, it's a little bit different, right?
Mm-hmm.
So can you show me an example here of the commutative property?
So 3 times 2 right here
Yep.
is the same as 2 times 3.
Right here. Okay, and so visually, whereas addition, you're swapping what goes first and second in the line. What's the relationship? What changes between these two that you just pointed out?
You're kind of rotating it.
You're rotating it.
It's the same with areas, kind of.
That's
because 3 times 2 is 2 times 3, which would be 6 as your area.
Okay, very good. So you're saying basically, even though you're not joining things in the same way as addition, it's kind of different because the shape always stays the same. The shape of the final quantity always stays the same, right?
Yeah.
Up here. Forget about the fact that we put the glass in there. If you stuck all these together without the spacers, the shape would always be the same, but the shape is a little different here because it rotates. So that's something important to keep in mind about the commutative property of multiplication is it rotates the area, which for addition, it doesn't change the shape at all. Very good. Okay. So is there anything else you wanted to talk about with this?
No, I don't think so. I think that wraps it up.
Okay, great. So we've covered a lot of ground in a short amount of time. And thanks for watching.
Yeah.
We will see you soon.
And please watch our other videos.